Here's the area of a kite. The numbers given, 6.2 for the long sides, 3.3 for the short sides. There's two configurations. Either the kite is convex, and in case it looks like this, or it's more like a dart or an arrowhead, whatever like this. The thing is, though, what we can do is split the kite into two triangles. So you've got this triangle, isosceles triangle, right, because two sides are the same, with a 25-degree angle in here. And you've got this other one down here. And either I'm going to add the two areas of those triangles to get the area here, or I'm going to subtract them to get the area up there. So what I got to do is I got to figure out what these areas are, and in particular I need to know what that angle is right there. But let's focus first of all just on this triangle here, the top part of that kite. If I drop a perpendicular from here to there, I can think of the area of that triangle as 1/2 the base times this height. Well, this height is in a right triangle now with that 6.2 side length for the hypotenuse and a 25-degree angle right there. So that red side has length 6.2 times the sine of 25 degrees. Right? And so the area here of that triangle, so now let's how are we going to do this? Let's do this in green here. So I've got, that's not what I meant. I meant this in green. So this triangle here, this whole thing, has area 1/2 the base, 6.2, times the height, which is 6.2 sine of 25 degrees. Okay? And if I type that into my calculator, I get 8.1227 and some change. Now I need to figure out the area underneath here. Now, one thing to notice is that the sum of the angles in that kite is 360 degrees. Each triangle is 180 degrees, and so the total is 360 degrees. I know that this angle right here is the same as that angle right there. So can I use that information? Actually, I think what I need to do is find this side length right here, that diagonal going across, because then I can use the law of cosines to figure out what this angle is. So to find that side, let's just call that x for now. I use the law of cosines on that triangle up above, because x squared is equal to 6.2 squared plus, oh goodness, I'm doing this the hard way. I could use the law of cosines, but here's an easier way to do that. Drop a perpendicular right here, right? So that's going to cut that in half. So x divided by 2 is equal to 6.2 times the sine of that angle right there. 6.2 times, because it's the opposite side here. So I got the hypotenuse, I want the opposite. I'm going to multiply by the sine of 12.5 degrees. So anyway, x is equal to 12.4 times the sine of 12.5 degrees. And I type that in my calculator, and I get that this is equal to 2.68385, whatever. All right, so now that I know x, I can use that to find the area of this triangle down here. Now, maybe I could just use, oh goodness, there's all sorts of ways we could do this. I think probably the slickest thing to do is again to drop a perpendicular here, um, and uh, and then use just half of x. I'm gonna look at this triangle here, and I can, if I know half of x, I know the hypotenuse, I can find that other side without even finding angles. So, and that other side I can use as a height for the x going across, base times height times a half. Okay, so that's my plan here. I'm going to call this length here y. And so if I take x and I cut it in half, that's just that piece right there. So x cut in half is 1.3419. So 1.3419256, whatever, squared plus y squared is equal to 3.3 squared. So I can calculate y by the square root of 3.3 squared minus, make that look good, minus this thing here, right? Now I'm doing it on my calculator, so I'm carrying as many decimal places as I possibly can here. So I've got the square root of 3.3 squared minus answer squared. So I get that y is 3.0149, whatever. Okay, so this x right here times this y times a half is going to be the area of that triangle down below. Right, so the area of this triangle, whoops, that doesn't look very good. That looks better. So the area of this thing is equal to 1/2 times 3.0149 times 2.6838. Right. So take this number, we're going to multiply it by half of x. And I get an area of 3.964. So the area of the convex kite is the sum of, this was an area right here, right? Area. So the top part of the kite is that, and the bottom part of the kite is this, and you just add them together. To get the area over here, you just subtract them. Okay, and I didn't do those final things, but you can. It's easy enough to add those two numbers together, and it's easy enough to subtract those two numbers together to get the results. So there you go. It used some different things. There were times when I thought about using the law of cosines. It could have worked. It would have worked, but because of the symmetry of the situation, I could see that dropping a perpendicular was going to be quicker, and I could just use my standard trick. So anyway, there's that one.